Well, hello folks. Hope everyone's doing well. We're going to do 14.2, the second part for the math equation in this lecture. We'll try to keep it as concise as we can, but let's get going. So the equation for molality, not molarity without the R, is mole of solute, just like the last one, but the bottom part is very important. Instead of liter, it is now kilogram. And the most important part here is instead of the solution, which is the total mixture, this is simply the solvent, which is the liquid that's doing the dissolving, or the part of the mixture that is the biggest percentage in the mixture. So let's read this question. What is the molality? So we're looking for molality already. Straightforward there. We don't need to rearrange the equation. And we know what equation it is. And you get gram of lithium fluoride and then gram of water, which is the solvent, because water is the universal solvent. Here we also have the molar mass of lithium fluoride, so that means we have to convert from gram to mole. Okay, so let's just do that first. We have 50.8 gram to mole, and 1 mole is 25.94 gram. Cancel the gram. And this gives us roughly 1.96 mole. So we have the mole. Molality is once again mole of solute over kilogram of solvent. We are looking for molality, which is italicized M, not capital M. We already got the mole of solute. Do we have the kilogram of solvent? Once again, a kilogram of solvent is related to this number, but it's in gram. Hopefully you guys remember that to go from gram to kilogram, you divide the number by 1,000, or simply move the decimal 3 decimal places to the left. So our solvent is 0.5060 kilogram of water. So now let's just plug it in and we should be good. So molality is the number of moles of solute divided by the kilogram of solvent. Easy one, we just punch it out. And if we do, I get roughly 3.87 mole over kilogram, because the unit do not cancel out, or 3.87 italicized M, which stands for mole over kilogram. Capital M stands for mole over liter. This one is a little complicated because you have a plus sign in the bottom. Sometime I will substitute solute and solvent. Apologize, I have an extra S right there. With X and Y to make it a little bit easier to rearrange. So let's read this question. What is the mole fraction? So we're looking for mole fraction. Obviously, we know we're going to use a mole fraction equation. We already have solute and solvent given in mole. So this is an easy question just to get you familiar with it. You don't have to do any conversion or anything like that. We know 3.5 is the solute because the solute is always a smaller number, and 55 is the solvent because the solvent is the bigger number. So mole fraction equal, in this case, we know we're looking for this. I can just plug it in. The smaller number is 3.5 mole. The bigger number and the smaller number is in the bottom. So I end up with 3.5 mole. 55 plus 3, 58.5 mole. The unit cancel out. So there's no unit with this mole fraction ever. You punch it out, 0.0598 mole fraction, no unit. So here once again we see the word mole fraction. So we know we're going to use the equation for mole fraction. We're trying to calculate the mole of NaOH dissolved. Dissolved means the solute is being dissolved. So I'm going to look for mole of solute. That's my question mark. And I'm given gram of water, Water is the universal solvent. But I'm looking for mole fraction, and everything in that equation is mole, so I have to convert it from gram to mole first. And we're given the molar mass in this case is 18.015 gram for 1 mole of H2O. If we do that, we will get, I don't know, I'm guessing 12.789 for my calculator, mole of H2O. So now let's plug some of this in and try to do it. Or you can do the rearrangement first, it's up to you. But for me, I'm just gonna plug it in because it's easier for me to see numbers instead of words. So mole fraction, I'm reading the mole fraction is 0.7 something right there. So it's pretty straightforward. So 0.1739 equal to mole solute, which I don't know, let's call that X, divided by mole solute again, plus mole solvent, which is 12.789 mole. Okay, so let's cross multiply and divide. When I do that, X times 1 is X. X times 0.1739 is 0.1739X. This is just distribution in math. Plus 12.789 times 0.1739, 2.22 roughly. And that one has the unit mole in it, so I have to keep the unit mole. I see 2x, I combine like terms, so I want to get rid of this. The opposite of adding is subtraction. And what if I do on one side, do on the other side? So this x right here is obviously 1. So 1 minus that, I end up with 0.8261x equal to 2.22 mole. But I want x, not 0.821x, so I want to get rid of that number. That's being multiplied by x by doing the opposite, which is divide. And once again, whatever I do on one side, I do onto the other side. When I finish with that, I have x, which is my number of mole of solute, is roughly 2.687 mole of NaOH. By the way, NaOH is the active ingredient of soap. I'm hoping you guys will understand that most of my examples lately tell you how important it is to understand solution, whether it's saline solution for people who are in a coma or being on a respirator, or concentrated soap in this case for disinfecting surface when you spray it out over surfaces. This last equation is pretty easy. It's kind of like Boyle's law, where it's P1V1, P2V2. This is an indirect relationship. So M stands for molarity because it's capital M. V is obviously volume. So reading this, pretend I have a patient coming in as a young child who has high temperature for fever. We don't know if it's the flu, the cold, or something else. And you can't give them pills because it's a little child. They can choke on it. You have to give them liquid Tylenol. So the pharmacists have a concentration of 8 molar, but you can't give that to a young child that's normally given to an adult, so you have to dilute it to 3.5. So I see 2M, I see milliliter, which is volume, and I'm asking for how many milliliter of this concentrated I need to dilute. So I also have volume. So before it is 8 molar and it's concentrated, after it's 200 milliliter and it's lower down to 3.5, which is less than half the concentration originally. So from that I know it's M1V1 equal M2V2. What am I looking for? I'm looking for V1 because I know the volume after I finished making the product. So I want to get V1 by itself. That means I need to get rid of this M, and the easiest way to get rid of something multiplies divide. And what if I do on one side, I do onto the other side. So that means I already have V1 by itself. Just plug it in. V1 is equal to M2 times V2 divided by M1, the concentrated original one meant for adult. The 2M cancel out. The only unit I have left is milliliter, which makes sense because I'm looking for milliliter of volume. So if I were to do that, 3.5 times 200 divided by 8, I need to get 87.5 milliliter of this concentrated Tylenol, put in the bottle, fill it up with some syrup and some water, maybe some grape flavoring or cherry, until it reaches the 200 milliliter mark. Shake it up, and I give it to the parents to help take the symptom and the fever down for the child. Hopefully you guys can understand this. If not, I am wide open pretty much every day. I only have 1 or 2 junior making an appointment with me every other day. The freshmen are doing it 3 or 4 times a week at least. So if you guys need help, feel free to make an appointment by just emailing me the day ahead, and I'll schedule you with something that works. Stay safe.